I'm Alex with Co-Architects. Partner Arnold is in the room. We've got Julie and Kaiwen here. I'm just going to do a quick introduction to kind of ignore everything that Omar told us yesterday. Is to have a single presenter so that we could keep this on track. So first I want to just thank John again from Boston Valley, but also Andy and Andrew. I think Andrew is heavily sleep deprived. He's probably passed out somewhere from moving everything. But I mean, amazing just to collaborate and to work with you guys over the past few months. I'm here to just share a little bit. Co-Architects, we've kind of experienced a lot of growth in the last 3 to 5 years. I think as partners, Arnold and I, our charge is to instill and continue to instill this culture of making. Culture of discovery in the office. As you grow as an office, it's a difficult balance. So events like these are extremely important to instill that on junior staff, and maybe selfishly also remind ourselves why we do this, why we enjoy architecture, because sometimes the world and what we do every day is a little mundane. So what we did at Co-Architects, we use this also as a vehicle to explore, but also foster a design dialogue within our office. So Sanjeev and Mick were extremely patient with us because we actually ran a little internal design competition prior to actually engaging in ACAW. We encouraged our staff to break down sort of project silos and boundaries, partner up with friends and others, and come up with some ideas for a month over Christmas. Merry Christmas. And then out of that, we sort of selected one team to proceed into ACAW and kind of develop their design. So I'll just go to the next slide. So some of the teams that presented had to do a lot with what we're seeing here today, with what students presented actually over the last 2 days. A lot about making mass light 3D printing. Exploring, bringing striation into actual terracotta extrusions, but also going backwards to simple roof tiles that were formed on your thigh and kind of seeing where that could go. So there were some really interesting ideas, but in the end we kind of went with basically our scheme here that now Julie and Kaiwen will share with you a little bit.
Thank you, Alex. So the project started we're looking at the how people use terracotta, and we also found out that terracotta is like a very rich material. You can have glazed and unglazed area that works as a half function, but we also found out that the common way we experience terracotta, we always has a front side and back side. So we kind of ask ourselves, how do we experience terracotta from all sides? Can we associate the function and geometry, also the material with unglazed and glazed area to our module pieces? So we started looking at the facade system with the panel options. And we're also looking at this into a front options, which gives us more like a 360-degree dimension.
So how can we embrace the different materiality of terracottas? This is our idea with 2 V shapes to create an aperture at the center. And this geometry is from origami's folding paper inspirations, and to create an internal channel and external channel with glazing and non-glazed surface. So to run the water or hold water so for us to grow the plants. And this channel can also provide the room to run structure and watering systems. And the module. And in the design process, we start to look into our module, and our module is like 3 feet tall and 1 foot wide. We think it's a good size for the openings. And also, this module is not simply out of a rectangular box. It's actually out of a parallelogram extrusion to increase the viewing angles, which is our goal to create 360 degrees terracotta screens. And the module has the flexibility to create a variety of patterns. So in our conversation with Boston Valley, we start to learn that we probably need to look into like more detail, like how we are going to fire the modules. It would be extremely hard to fire in vertically. And also the size, original size we have, like 3 foot tall, also make the, we'll lose the very, within the 6 foot by 6 foot framing, it's hard to tell, like we can create a very like pattern. So with these sides, we start to looking down to how we want to shrink it down, and maybe how if we need to split the module into 2 pieces. So this is our study and some like variation of the patterns. So in the end, we decide to split our module horizontally and to have like one V to be only 11 inches tall. And we also, like in the module fabrication, we decide to have the slip cast, to use slip casting to cast our module. The major challenge is how we can remove the mold from the channel, and if we keep the module as a whole piece, it's basically not possible. And for testing mass production, we also agreed to fire the module horizontally. So this is actually increased risk that's like very hard to predict how much the terracotta is going to shrink. And the design of fitting. So we Ben from Tri-Pyramid helped us to design the fitting. Our system is supported in hanging from 316 tension rods with fitting grabbing the 3 points. We would like to keep the flexibility of like rearrange our module patterns. So we also design the fitting in module. And so the fittings combines with the clamp and pin connection and clipped. Like in this corner, this is the fitting combination you will need. Also, ACAW has an in-house model shop which allow us to 3D print a mock-up and test the design. We built a little mock-up in 1:1 scale to make sure the size of fitting is working. And in our first round, we kind of realized we need to adjust our fitting because it doesn't have enough room for us to slide in the terracotta module piece. So rearranging that, and we resolve the issues. However, this testing only works if the terracotta shrink within our expectation and the tolerance we designed for. So this is the final layout of our ACAW project.
So when we're looking at glazing and texturing for these pieces, we think terracotta and glazing has like very contrast experience when you look at it, even when you touch it. So we are thinking, how do we use the glazed and unglazed area to emphasize the concept of the flow, and also building textures to give a second layer of the experience. We started with watercolor sketch to kind of like text out how we wanted to see this module, and we ended up with this diagram shows we have most of the glaze and texture area in the channels, and which is the result of we wanted to see when we have multiple modules in a row, and that could keep the reading of the flow and potentially have water flow between them. We leave the flat surfaces of our module to be unglazed and leave the clay body there because we also use these surfaces for firing. Sorry. And because we're using slip casting, so we have the ability to build in the texture in the mold when we do the casting. And we also consider for manufacturing purposes and quality control, we might need the texture to go out with the same direction when we do the demold. We do a lot of studies for to test out what's the texture and the scale we really want to apply in these surfaces. We come up with the way to cut out the a printout paper and attach on the 3D print surfaces model we have, and we ended up with this line texture because it matched our concept back to the flow idea, and it's had better quality control. We work with Andy on looking at different texture with glazing testing, and we're very excited to see the first firing. So this picture is showing that what we decided this color, and we also really like the outcome of the gradient of how that works with the clay body with different thickness on the surfaces. So this is the picture from the ACAW final. We surprisingly found out that the sunlight gives a second read of the clay body as well with the shadow on it. And this is a close-up view of the channel with texture. And this is the other view of looking at the texture with the strong sunlight. We really like this outcome. Although in the assemble process, there's a lot of unexpected shrinkage. We use a lot of shim, but we finally make these pieces, and we're really happy for that. And it's also a surprise for us to find there's a lot of variation that we can look at these pieces that we didn't really think about it before.
So going back to architectural application, we still looking forward to making the module in full size without splitting, which we think it may help to control the geometry in fabrication process and also simplify the anchorage design. So we probably can just use 2-point connection instead of 3. And so here are some samples of pattern variation we did, and then in our final ACAW markup, we try to combine 3 patterns within it. And then, so this is this pattern we want to share, the possibility of our module and some other color glazing study can create another layers of variations. And interior to show how the shading it provides, and a really interesting shadows pattern. And we also did a little study to see how it can affect the shading and light quality for the interior space. And this rendering from outside, it shows the module for experiencing in 360 degrees, which you can randomly remove patterns or rearrange for your green screen. Thank you.